Good afternoon, everybody. I'm presenting to you all the way from Cape Town, South Africa. And thank you very much for the opportunity to chat with you this afternoon. I am the product manager for Anchor. And so I look after product development, brand management, pretty much everything to do with the Anchor brand that is distributed by Freitas Velar here in Portugal. So today I would like to chat to you about really how we've created blends of yeast and bacteria and how you can use them as tools to enhance the wine quality. So for the first section, I'll focus on really how and why we created blends of yeast that became the ALCHEMY range, and really how they are able to enhance the flavor and the aroma of the wine. So of course, many winemakers, you blend your wines, taking different elements from different wines to create something unique, something different, and something that is more complex than what you would have by just using the individual components. So we have took the same concept, the same idea, and applied it to yeasts. So we created the range of ALCHEMYs. These are all blends of yeast strains, and the idea is really to also create something more unique, more complex than what you would have when you use just the individual strains. So how did we do this? We went to the Australian Wine Research Institute to discuss how we could create blends that could enhance quality, flavor, aroma. And at the end of this project, we were the first company in the world to launch commercial yeast blends based on the interaction between the different strains in the blend. So this is a very simple view of what Miguel discussed in the first session, but for the development of the blends for white wines, we decided to focus on thiols and acetate esters, and for the creation of the blends for red wine, we decided to focus on monoterpenes and then also ethyl esters. So as Miguel explained, why is it important to have a blend, especially for the white wines, is really you need that combination of strains that can release thiols and then also convert it. The reason the conversion is so important is because the detection threshold is almost 15 times lower for the ester 3-MHA, which means you need so much less of it in order to have a big impact in the wine. So in order to create the blend, we follow 3 steps. First, we look at the contribution of the individual strains. So for the creation of the blends for white wines, first we looked at the ester contribution of the strains, looking at the esters that could enhance complexity, fruity aromas, floral aromas, and here you can see the 3 yeast strains that performed the best in terms of the ester production. We take the same concept, looking at how the individual strains can enhance the thiol concentration. And here, once again, you can see the same 3 strains perform quite well, especially for the 3-MH and the 4-MMP production. The final 2 steps of creating the blend is really, we have to see if the blend works, what is the impact if we ferment them together. And the last step is to see how and which ratio of the different strains have the best and the most positive impact in the wine. So here you can see the two blends that eventually became Alchemy 1 and 2 in comparison with individual yeast strains and how they perform when producing the thiols 3MH and 3MHA. So you can see the blends clearly have an increased concentration of 3MH and 3MHA compared to just using the strains by themselves. So this led, as I said earlier, to the world's first blend of yeast, commercially available wine yeast. Alchemy 1 is a blend of 3 strains that is specifically designed to increase the ester concentration. And Alchemy 2 is a blend of exactly the same 3 strains, but in different concentrations, which is very much designed to really increase the thiol concentration of white wines. So we were very happy with what we were able to achieve in white wines and wanted to apply the same concept in red wines. So we went back to Australia with a similar process, looking at the performance of the individual strains, seeing which blends of strains work the best. And the third step is to really very scientifically look at which concentration of each strain gives us the best result. So I'll just show you the final result that we achieved in that project. So here you have 3 blends. These 3 blends contain exactly the same 3 yeast strains. But as you can see, just by changing how much of each yeast strain we have present in the blend, we can either push the sensory profile to much more dark fruit, kind of dried fruit structured profile with blend 1, and then blend 3 really performed very well in terms of enhancing the fruit profile. Very red fruit driven, strawberry, raspberry, cherry characters. So those 2 blends eventually became Alchemy 3 and 4. Alchemy 3 very much for structured, darker kind of profiled wines, and Alchemy 4 100% for enhancing, really enhancing the red fruit characters in the wine. When you compare, analytically compare the two blends, remember they have the same 3 strains, but just in different concentrations. You will see that Alchemy 3 in the solid line really enhances the complexity with 2-phenyl ethanol production, quite a lot of acetate esters happening. Whereas Alchemy 4 in the dotted line, in the pink dotted line, really pushes the fruity ethyl hexanoate and also the total ester concentrations. So you have to remember 3 things. Firstly, these compounds are produced in concentrations that are higher than the odor threshold, so they really have a real impact on the wine aroma. Secondly, these are also stable compounds, which means that they play a role in the aroma profile even after tank, barrel, bottle aging stages, and they still have a real effect in the wine. And thirdly, we've noticed, and we are investigating with a research project, that both of these blends actually reduce the methoxypyrazine concentration. So you have a real effect in decreasing the green characters, maybe more harsher green tannins that are definitely less impactful with the 2 blends, Alchemy 3 and 4. So now we have the world's first blends, Alchemy 1 and 2 for white wines and Alchemy 3 and 4 for red wines. Really designed to be able to enhance complexity, create unique wines, and really increase the aroma and the flavor of the final wine product. We were so happy with what we managed to achieve in the yeast portfolio with the blends that we decided to see if we could create something similar and with similar success in bacteria blend. So we created the world's first bacteria blend in the duet range, which are blends of Unococcus uni and Lactobacillus plantarum. So the way that winemakers select bacteria cultures have changed quite significantly over the last couple of years. Initially, it was really a decision based on fermentation kinetics. Then how does the different bacteria tolerate different parameters, alcohol, pH, sulfur, etc. Then came the whole movement in terms of exports and audits with regards to things being produced like biogenic amines. And now finally, I think we have moved to a space where we can talk about bacteria in the same way as we do yeast. And by that, I mean, it's assumed and it's given that you have a fermentation, a malolactic fermentation happening, but you can actually use the bacteria to enhance structure or spiciness or fruitiness, obviously depending on what you want to achieve in the final wine, like the different wine styles mentioned for white, rosé, and red. So how Anchor approached this way of thinking about bacteria is we created very selected and characterized bacteria cultures that are blends of Unococcus uni and Lactobacillus plantarum. So currently the range consists of two blends, Duet Aroma and Duet Soft. So of course the first question is, why would we blend them in the first place? And we'll look at 7 major factors and reasons why we did this. First, of course, security is always important. Will you have a secure, complete fermentation? And the blend allows for this because of the inclusion of the Unococcus strain. We created blends specifically for co-inoculation to get the benefit and the contribution of the Lactobacillus plantarum strain. We will look at what the impact is on the production of volatile acidity, the production of diacetyl, the so-called battery character. We will look at why does this blend actually have a significant impact on the sensory profile of the wine. Of course, the question I get all the time is what happens when you use bacteria during co-inoculation and what is the impact on my color? So we will look at some examples of that. And then lastly, I just want to show you how you can actually use the blend of bacteria to use it as a tool for bioprotection in the wine. So first aspect, security. As you know, the 2 genera of bacteria have quite different parameters that they like to work under. And Unococcus uni is the so-called workhorse in the bacteria family. So by creating this blend of bacteria, we have the security aspect and the knowledge that you will have a complete secure fermentation over quite a wide variety of parameters in terms of alcohol tolerance, sulfur, etc. Secondly, as I mentioned, these blends are specifically developed for co-inoculation. And the reason they work so well together with adding the yeast and the bacteria at the same time is, as you can see, lots of benefits. But co-inoculation really gives you the opportunity to have a complete malolactic fermentation if you have a more difficult wine to deal with. Say you have a larger initial sugar concentration, which would mean that a larger or a higher alcohol eventually would make sequential fermentation difficult. So co-inoculation is a really good tool for that. You have less risk of spoilage.
Mi raccomando.
you have less risk of spoilage because the processes happen at the same time. And of course, there is a very big difference between the impact of co-inoculation on the sensory profile and the impact of sequential inoculation. So obviously, I have many questions about using bacteria in co-inoculation when there's quite a lot of sugar involved. So here the blend plays a very big role because, as you know, Eunococcus uni is heterofermentative, so it produces not just lactic acid and CO2 from glucose, but also ethanol and acetic acid. So how we manage that in the blend is really to go through a very strict screening and selection procedure. So we actually have an Eunococcus uni strain that produces low levels of volatile acidity. The reason why the blend is so important is the fact that the Lactobacillus plantarum strain is homofermentative and actually will not increase the volatile acidity concentration at all, just produce lactic acid from sugar. So by having the blend, we immediately lower the impact on the volatile acidity, and you actually have either the same or less being produced compared to sequential inoculation. So diacetyl, it's either something you want in the wine or you don't, depending on the style that you want. But the production of diacetyl is linked to the citric acid metabolism of the bacteria, and it's a mechanism by which it reproduces coenzyme NAD+. So what happens in a sequential environment, you don't have a lot of sugar and the bacteria automatically degrades the citric acid, which produces more pyruvate, and as a result, more not just diacetyl, but the other carbonyl compounds as well. In comparison, when you have co-inoculation in medium, so lots of sugar around, the yeast actually prefers the malic acid to the citric acid. So rather use malic acid, less citric acid being metabolized, less pyruvate, and as a result, you have less diacetyl being produced in co-inoculation. So less battery characters and less of a risk of the diacetyl actually masking other aromas that usually help with complexity, and it can also be an instigator of oxidation. So co-inoculation results in less diacetyl. Okay, so probably the most important reason why we have a blend is really because of the sensory impact. Just by nature, the plantarum strains tend to be more complex in their enzymatic profile, so they naturally lend themselves to having a more complex impact on the aroma. So here we've actually analyzed the Lactobacillus plantarum and Eunococcus uni strain in duet arome. And as you can see, the plantarum strain actually has beta-glucosidase activity. As Miguel explained, the bacteria can actually take the bound precursors that are not volatile, metabolize, and with its enzymatic activity release these compounds to actually help and add to the sensory profile. It can release amino acids that can actually be precursors for the production of other aroma compounds. And of course, it can also add to the esterase activity, so more esters being produced. So just by the nature of the blend, having the plantarum strain in there as well, we have a more complex contribution as compared to just using a Eunococcus uni strain by itself. So how we can see this is we compare duet arome, which is the blend with the beta-glucosidase plantarum strain in comparison with 2 Unococcus uni strains in co-inoculation. So clearly you have a significant increase in these monoterpenes and norosopranoid compounds that actually add to the fruity and floral profile of the wine. So a massive impact just by comparing the blend versus single Unococcus uni cultures. The blends themselves are also different because the strains, the Unococcus uni strains and plantarum strains are unique and different in both blends. And you can see if you look here at the top in the blue bar, which is Duet Arôme, you have a much larger impact on the fruit aroma profile compared to the green bars here, which is Duet Soft, which really impacts more on the mouthfeel, the tannin perception, and the color intensity of the wine. So
Elda,
the blends allow you to have different sensory impacts on the wine. A question I have very, very often is what happens to my color if I do a co-inoculation malolactic fermentation? So we investigated the technique of using micro-oxygenation with the bacteria. And here, before we even compare with and without oxygen, you can just compare co-inoculation with sequential inoculation. And clearly, co-inoculation has a bigger impact and leads to an increased color intensity compared to sequential. Then when you compare the co-inoculation treatments without oxygen and with oxygen, the treatment with malolactic fermentation with the blend, together with the micro-ox, results in the highest color intensity compared to the other treatments. So the answer to the question I have from winemakers, it's perfectly fine. The impact on the color is actually a positive impact compared to sequential inoculation. Another project that we did is to compare the differences between co-inoculation and sequential inoculation and the impact on the anthocyanin concentration. So here, once again, you can see, irrespective of the blend, just purely in comparison with Unococcus uni and sequential, you have significantly higher anthocyanin concentration. So the co-inoculation with the blend has a positive impact on the color, and Duet Soft has the biggest positive impact out of the two blends. Okay, so now we've compared sequential inoculation and co-inoculation, but what happens if we compare bacteria cultures under the same co-inoculation conditions? Is there actually a difference in how they impact the color? So here you can see on the left color intensity and on the right graph anthocyanins, and the blended cultures always have a positive impact on the color. As I said, Duet Soft seems to have the biggest impact, but I just want to put your mind at ease that using the blends, using co-inoculation is a really good tool to enhance the color of your red wines. The last concept that I just want to touch on is how you can use co-inoculation and the blends as a tool for bioprotection. So it's obviously a topic that is being discussed quite a lot in the wine industry, and the tools here with the blend of bacteria and co-inoculation work in two ways. First, you can actually decrease the amount of sulfur you add at crushing because by inoculating the yeast and the bacteria, those inoculated populations will dominate any indigenous microorganisms you have. The second mechanism is because the two processes, alcoholic fermentation and malolactic fermentation, are happening at the same time, you don't have that spoilage window that you would have with sequential, where you're waiting for the one process of alcoholic to finish in order to start the next one for malolactic. So using the blends, using them in co-inoculation actually allow you to have more of a bioprotection mechanism and be able to use less sulfur. And the wines are then ready to be processed further a lot sooner. Okay, so hopefully after that, you have a better understanding of how these two concepts could work together. You can create more tropical fruit-driven wines with a softer mouthfeel if you look at comparing, combining Duet Soft with Alchemy 1. Really structured, darker kind of profile wines with Alchemy 3 and Duet Soft while still having good mouthfeel. And then an absolute fruit-driven profile with Alchemy 4 and the combination with the Lactobacillus plantarum with beta-glucosidase activity in Duet Aroma.